Alright, so last year I noticed that for some strange reason, when I went into YouTube and looked at the, what are the words, analytics of my YouTube channel, I discovered that for whatever reason, there were like a few random views of my videos from super strange, faraway countries. Not that the countries are strange, but it's strange that they were watching my videos, like Australia and Japan and I don't know, Papua New Guinea. I made that up, but random places or seemingly random to me places were watching a few of my videos, and I'm sure it was an accident. But if that's happening right now, then you're probably going to think it's really weird that I'm sitting here explaining math problems to myself while my mom brings me chili. But anyways, that's what's happening. If you're one of my students, you know why my mom's bringing me chili. But if not, or if you didn't listen on the first day of class, then you also probably think this is weird. But anyways, let's do this problem. Use the graphs of f of x and g of x to find these values. Well, Mr. Reed, now would probably be a good time to actually show you the graphs. There you go. So here's the deal. We didn't really talk about this in class, but this is actually exactly like the tables when you use the table to evaluate a function or a composition of functions or a combination of functions like b here. So again, it all comes from understanding how to read the information. So first off, notice we do have function notation and composition of functions in most of these. So with the composition of functions, like part A right here, notice that the inside function is function g. So that tells me I'm looking at this graph over here, the graph labeled g, and that -2, remember, when a value is inside the parentheses of a function g, that's telling you that that value is an x value on that function g. So I need to go to g, I need to go where x is equal to 2, I need to figure out what the corresponding y value of my graph is. And it's kind of hard to tell in this, but I drew it last year. It's supposed to be linear like that with a slope of 1. So the x value of +2 should not be -3, it should not be -2, but it should be -1. So this question gets to be rewritten. Instead of saying f of g of -2, I can just say f of, what did I just say it was? -1. And again, that -1 is the output from this g function. It's that y value, it's the output there, but it becomes the input of my f function. That's what a composition of functions is. It's like taking an output and using it as an input in a different function. Whoa, I don't know why I've never said that before. Maybe that makes sense to some of you. So now let's figure out what f of -1 is. So I look at my f graph, that one right there, and then I go to the x value of -1, and again, this one should also be linear. They should all be linear, but Mr. Reed, he didn't use a ruler. Bad example, Mr. Reed. And he only put some random dots on there, but there's the rest of them. So anyways, the x value of -1 gives me a y value of a +2. So I get 2 there, which means that original function composition notation, f of g of -2, equals +2. Sweet. Let's look at part B now. Part B says f of -1. Whoa, Mr. Reed, come on, you kidding me? We just did that, so I don't have to even do anything, because I know that f of -1 is 2. Sweet. So g of 3, what about g of 3? Well, g of 3 says go to the x value of 3 and tell me the y value. The y value is 0, so what? Are you kidding me? That just equals 2? That's the same as that one right there. That's nuts. F of -1 plus g of 3 equals f of g of -2. That doesn't really mean anything. That doesn't have any interesting implications, but it did happen. So that's kind of weird, and we can note it. F of 0, then, if I now go to this last one down here, part C, and I'm talking about f of 0 first, because that is the innermost function. So, f of 0 says, go to my graph of f, go to the x value of 0, and find the value. So the value is right there, right? It's 0, isn't it? No. No, it's not. I would have drawn a picture of an angry grandmother tisk-tisking her finger, but I don't know how to do that. Notice that is an open circle there, and this is a closed circle up here, telling me that the function's value actually exists up here, not down there. And if it existed in both places, then we'd be in trouble, because that would not be a function. It would be a relation, but it wouldn't be a function. So my value there is positive 3. So this becomes G inverse of positive 3. So let's talk again about what we said a moment ago. If you see a number inside a function notation set of parentheses, it's telling you that that is an x value on whatever function it is attached to. So this is attached to G inverse. So 3 is an x value on G inverse, which tells me that 3 is a y value on the G function. And if you think of G inverse of 3, that's asking me to find the y value on the inverse, which means I'm finding an x value on G. Zhong is what that says. So I look at my G function, I find where the y value is equal to 3, and I use that corresponding x value. So G inverse of f of 0 is negative 3, because I'm using that x value where y is equal to 3. Sweet.